Hi everyone, my name is Danny Vole from the Swinburne node of ADACS, the Astronomy Data and Computing Services. In this tutorial, we will cover the basics of the important topic that is version control. We will cover an overview of the topic with examples using the version control software Git. In this tutorial, we will first cover an introduction to the topic, including what is version control and why we should use it. Then, we will cover the basics to get started and set our computer environment. This will be followed by the topic of commits, branching, merging, and dealing with conflicts. Finally, we will look into a few options to use version control collaboratively, including solutions working over the web. Version control, sometimes called revision control or source code management, is a system to record and manage changes posed on files and repositories. It is commonly used to manage source code, but can in fact manage any kind of files. It is suitable, not to mention viable, both to manage your own files and the files of your team. It enables safe and efficient collaboration on projects. If this is a new topic to you, note that you probably already use some kind of version control of your own. These are mechanisms that you use to stay organized in a project and keep track of the evolution of the project. Many modern software have built-in mechanisms to track changes. You might have done something like this, where you have file 1, 2, 3, and so on to mark the versions of your file. Within the version control world, these are called revisions. And then you would have your final product, which would be the final paper, for example, that you sent. Why using version control? Because it enables better reproducibility. For example, astronomers write more and more code every year. Keeping track of changes means we can reproduce results generated in the past. Version control provides means to tag code versions for later references via tags, record a unique identifier for the exact code version used to produce a particular plot or result via commit identifiers, roll back our code to previous states via checkout, identify when or how a bug was introduced via the diff or blame functions, keep multiple versions of the same code in sync with each other via branches and merging, and finally, efficiently share and collaborate on our code with others via remotes and online hosting. Note that version control is not only limited to managing code, it can also be useful when writing papers. For instance, we want to bring back that paragraph we accidentally deleted last week. With version control, we can try a different structure of our paper and simply disregard it if we don't like it. We can work on a paper in collaboration with others and then automatically merge all the changes together. For short, you should use version control for almost everything. The benefits are well worth it. As we mentioned previously, in this tutorial we will use Git for version control. Git is a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. Git is a distributed system. Every person has their own complete version of the entire repository. Every person can make changes, only commenting to or checking out from the central repository when needed. Classic centralized system like Subversion requires users to have access to the central repository to commit changes. With Git, you can easily work locally without a connection to the outside world if you have to. It is also a fast solution written primarily in C and shell scripts and was originally written by Linus Torvald, the creator of Linux.